Hi, good morning students. Here we can do some numerical based questions on the basis of half-life period as well as the integrated equations. That is, a first order reaction has found to be a rate constant of a first order reaction has found to be a rate constant of 5.5 into 10 raised to minus 14 second inverse. Then find the half-life of that reaction. Find half-life. A first order reaction. Here it is directly given, otherwise a reaction has found to be a rate constant of 5.5 into 10 raised to minus 14 second inverse. That is, by analyzing the unit of rate constant, you can find the corresponding order. Clear? Find the half-life of the reaction. Here we have to find out half-life. Given data is rate constant. Here K equal to 5.5 into 10 raised to minus 14, and you have to find out T half. The reaction follows first order kinetics. For a first order reaction, T half equal to 0.693 by K. That is 0.693 divided by 5.5 into 10 raised to minus 14. Okay? Or 0.693 divided by 5.5 into 10 raised to minus 14. 10 raised to 14. Or 6.93 divided by 5.5 into 10 raised to 13. 6.93 divided by 5.5 into 10 raised to 13. That is equal to 1.26 into 10 raised to 13. That is the T half-life of a first order reaction with the rate constant K equal to 5.5 into 10 raised to 14. Clear? And here is the next question. A first order reaction. A first order reaction is 20% completed. First order reaction is 20% completed in 10 minutes. 20% completed in 10 minutes. Calculate the time. Calculate the time for the completion of 75% of the reaction. 75% of the reaction. Here it is given in terms of percentage. And if the data is given in terms of percentage, then you can take initial concentration as 100%. Initial as 100%. Then one method you can do We know that the expression for rate constant of a reaction equal to K equal to 2.303 by T log A0 by A, or T equal to 2.303 by K log A0 by A. A0 is the initial concentration. A is the concentration after a time T. In the question, it consists of two parts. First one, it is given that first order reaction is 20% complete in 10 minutes. If a reaction is 20% complete, means the remaining concentration is 80. For that, it takes 10 minutes. Then, how long will it take to complete 75% or 3/4 of that reaction? That is the question. Okay? Here, in the first case, we have two equations. T 20% is 10. 10 equal to 2.303 divided by K log 100 divided by 80. How it becomes 80? 20% of that reaction is completed. Initially it is 100%, and out of 100%, 20% is completed, and the remaining is 80, and the time for that is 10 minutes. That is equation number 1. Okay, then you have to find out T 75%. T 75% means 75% of that reaction or reactant undergo reaction, and the remaining is 25%, that is T75. Here it becomes 2.303 by K log 100 divided by 25. That is 75% of a reaction complete means the remaining is 25. Here we have two equations, and we can further simplify that. 100 by 80 means it is equal to 10 by 8 means 1.25. Log 1.25, that is it is also equal to 10 equal to 2.303 divided by K log 1.25. Here T 75% equal to 2.303 by K log 100 by 25 means 4. Log 4. And what about equation? We have two equation. Equation 2 divided by equation 1. Equation 2 divided by equation 1 is T 75% divided by 10 equal to this 2.303, 2.303 by K get cancels. Log 4 divided by log 1.25. Or, log 4 is 0.6021. Log 1.25 equal to 0.969. 0.969. T 75% divided by 10. or T 75% equal to 0.6021 divided by 0.0969 into 10, and that value equal to 62.14 minutes. Okay, that is one method. You have to take two equations, and the alternative method for the same question, it is given, which is given, the time required for the completion of 20% is given, and by using this you get the expression for K, isn't it? K equal to 2.303 divided by 10 log 1.25, and 0.2303 into 0.069, because log 1.25 is 0.0969, and you get the value of K. For a given reaction, the unit of rate constant is always same. The unit of rate constant is same. Therefore, substitute the value of K in this equation. Here you get the value of K. That is the alternative method. I think the next question we can do in that manner. First we calculate the value of K. Then only you can familiar with the different method how to derive the equation for a reaction. Clear? I think all of you understand this. You have to try to solve this type of problem, which is usually asked for your previous board examination. Okay. And next question, a first order reaction is 75% completed in 32 minutes. 32 minutes. How long will it take? How long will it take to complete 50%? A first order reaction is 75% completed in 32 minutes. How long will it take to complete 50%? That is here also, as in the previous case. There are two conditions, 75% completed in 32 minutes. From that you can calculate the value of K. That is K equal to 2.303 by T log A0 by A, or T equal to 2.303 by K log A0 by A. Here T for 75% is 32. 32 equal to 2.303 by K log 100 divided by 25, because 75% of the reaction is completed, means remaining it is 25. Or we can directly substitute here, that is K equal to 2.303 by 32 log 4, because log 100 by 25 equal to log 4, or K equal to 2.303 by 32 into 0.6021, because log 4 equal to 0.6021, and that value equal to 0.0433. It is given in minute. minute inverse. That is the expression for, or that is the value of rate constant of a reaction from this data. That is, first order reaction is 75% completed in 32 minutes, and the rate constant of that reaction at that condition is 0.0433 minute inverse. Then how long will it take to complete 50%? 50% means, it is T half. 50% is T half. T half equal to 0.693 by K, or 0.693 divided by 0.0433. That means it is equal to 16 minutes. 16 minutes. If this question is asked for your board examination, and you can adopt this method or previous method. Previous method, we take two separate equations, that is T 75% equal to 2.303 by K log 400 by 25, or here 2.303 by K log 100 by 50, or log 2. Log 2, log 4. Okay? And the same question, if it is asked for a entrance examination, GMAIN or a NEET exam or anything, any competitive examination, if the same question is asked, where you can use the shortcut method to solve this problem. And in your board examination, suppose if it is asked for 3 marks, then you can adopt this method or the previous method. And the same question, when it is asked for the competitive level examination, you can do another method. That is, a reaction 75% completed means initially 100%. That is 100%, it is reduced to 50% is called half-life period. The time required to reduce half of its initial concentration is called a T half. 100 to 25% is the second T half, because 25 is half of 50. And you just think, that is, when the reaction is 75% completed means at present the concentration is 25. 100 to 25 means 75% of the reaction completed. That constitutes 2 half-life, 2 T half. The time required for that completion is 32 minutes. 100 to 25 means 2 T half, or T half equal to 32 by 2, that is 16 minutes. That is, if you derive this type of questions, it will take nearly 4 to 5 minutes, and it can be completed within 1 minute. The same question in the descriptive manner as well as in the objective type manner. You can practice in both ways. Okay? And one more question based on the integrated equation, that is, show that for a first order reaction, the time required for 99.9% of the reaction to take place is 10 times the time required for 10 times the time required for the completion of half of the reaction. That is simply show that for a first order reaction, the time required for the completion T 99.9% is 10 times than that of T half. You have to prove that, or show that for a first order reaction, the time required for 99.9% of the reaction to complete or to take place is 10 times the time required for the completion of half of the reaction. Here we can use two equations. Two equation means T 99.9% equal to T 99.9% equal to 2.303 by K log, that is initially 100 and 99.9% completed means it is 0.1. 100 by 0.1 means 1000. 1000 is 10 raised to 3. That is 2.303 by K log 100 by 0.1 is 1000. That 1000 means 10 raised to 3. 2.303 by K log 10 raised to 3. 10 raised to 3 means log 10 raised to 3 means 3 log 10. That is 3 log 10, that is equal to 2.303 by K into 3. Into 3 means 2.303 by K log 10 raised to 3 means 3 log 10. Log 10 is 1. That is first equation. And completion of half of the reaction is T half. T half equal to T half equal to 2.303 by K log 2. Isn't it? Log 2 equal to 2.303 by K into 0.3010. 0.3010, or you can use as 9096 point by K. Here you can directly use, both way you can use. It is equal to 0.693 by K, that is T half. Clear? And equation 1 divided by equation 2. Equation 1 divided by equation 2, T 99.9 divided by T half equal to 2.303 divided by K into 3 divided by 2.303 by K into 0.3010. Here it becomes T 99.9 divided by T half equal to 6.909 by K into K divided by 0.693. This value 9.97 approximately equal to 10. It also approximately equal to 10. That is T 99.9. T 99.9% equal to, when cross multiply it becomes T half into 10. It is T half into 10. It is clear that for a first order reaction, the time required for 99% completion is 10 times the time required to complete half of its reaction, or 10 times the half-life of this reaction. This is important one. If the question asks just to compare the different rate of a reaction at different conditions, you have to take separate equations on that. If anybody has some doubt based on this numerical problems, you can use the different method. Either take it as log 2 and find the value, or by simplifying the value. Clear? 2.303 into log 2, that is 0.693. Anyway, this is very easy and usually asked for this examination. And this is about chemical kinetics, and in this lesson we have studied, let us summarize or consolidate the different points of this topic. That is, first one about the rate of a reaction. Rate of a reaction is the decrease in concentration of reactant or increase in concentration of product in unit time. It is expressed in two ways. One is called average rate and other is called instantaneous rate. This instantaneous rate is preferred over average rate, and by writing the expression for average or instantaneous rate, we can find out the rate of disappearance of reactant as well as rate of appearance of product. And next is the term order and molecularity, the difference between order and molecularity, and the unit of rate constant, and how does the rate of a reaction affect if we change the concentration of reactant or product. Then pseudo first order reaction, and about the integrated equation for zero order as well as first order reaction. From that we deduce the expression for the corresponding half-life, and finally we do some numerical based questions on the basis of integrated equation for a first order reactions. Okay, that's about this lesson, and you just go through this, especially in physical chemistry lessons, that is up to kinetics. Surface chemistry, there is no such problem, numerical based questions, and you just go through the previous year or 10 years questions and solve by yourself, and if you have any doubt you can ask me. Okay, thank you.